Hi everyone, Mrs. Torigno here again. If you were watching my last video that was supposed to cover page 7 from the Geometry C exam review, I apologize, my battery ran out halfway through. So I'm going to pick up here with problem number 26, which is where I left off on the previous video. Question number 26, just to give you a recap, was asking us about angle 8 and angle 2 and how we could use the fact that those angles are congruent to prove that those two lines are parallel. Well, we want to pay attention first of all to what we know and what we're trying to show. Remember that when you're looking at a theorem, the if part, the hypothesis, is what you know, which means we are looking for a theorem that says if certain angles are congruent. The then part is what you're trying to show. So we need a theorem that would end with then the lines are parallel. If you think back to chapter 3 when we talked about all of these parallel lines, we first learned a whole group of theorems about all of these different angle pairs and how they were related, and that if we knew that two lines were parallel, these things were true about those angles. We knew that they were congruent, or we knew that they were supplementary. So those theorems were phrased, if two lines are parallel, then blah, blah, blah. Okay? Then we talked about the converses of all of those theorems, which said things along the lines of, if we know this type of angle pair is congruent, then the lines are parallel. Those are the theorems we want to focus on here, because we need to focus on one that ends with, then the lines were parallel. So I know it's the converse of one of the parallel line theorems that we learned. Okay? And now all I really need to know is what types of angles are these that we're talking about? Well, here's angle 8 and here's angle 2. And again, if I'm comparing them to the parallel lines, pretending that's a hallway, they are on the inside of the parallel lines, and they are on opposite sides of the transversal. Opposite sides of the transversal, means that they are alternate, and being inside the hallway means that they are interior. So this is the converse of the alternate interior angle theorem. Okay, so I would really just focus on knowing there how to identify these angles and what types of angles that they are. That's what's going to be the most helpful for your exam. Okay, 27 is actually along the same lines. 27 gives you a different diagram, but it's asking you what value of x would make these two lines parallel down here. Well, if these two lines are parallel, these two angles would be alternate exterior angles. Again, because they are on opposite sides of the transversal, and they are on the outsides of the parallel lines. So that's alternate exterior. And if we know that alternate exterior angles are congruent, then we know that the lines are parallel. So think about how I could write an equation that would make this congruent to that. Remember that congruent is the geometry word for equal. So I'm just going to set up an equation that says 7x plus 2 is equal to 86. Okay? And now I'm just going to solve for x, because that's what the question is asking. What is the value of x? So let's subtract 2 from each side. So I end up with 7x equals 84. Divide both sides by 7, and I end up with x being equal to 12. And that's it. That's your final answer there. Because if we know that these two angles are congruent, then the converse of the alternate exterior angle theorem tells us that those lines would have to be parallel. Okay, that's it for this video. I know it's a short one, but I will pick up the next video with problem number 28.